indirect or inverse variation. Under this, we can have an example where they say y varies inversely. And listen to the word inversely. Sometimes they can use inversely or indirectly as x and y. Inversely as x. Sorry about that. So you say y varies inversely as x when y is equal to 12 and x is equal to, let's say, 2. The number one, we say find. We can say, okay, find the value of k. The value of k. Number two, we can say value of x when y is equal to 6. Number three, we can say value of y if x is equal to 4. It's done. Very simple, guys. So same procedure, only 2 steps are needed. 2 steps only, not more or less. Number one, they say, as usual, they say solution. They say y varies inversely as x. So we write y varies inversely as x. Inverse, it means 1 over x. That's a key. Then number two, the moment you introduce an equal sign, we say y is equal to a constant of proportionality has to be introduced, the kappa, which is over that. So we can simply say y is equal to k over x. It doesn't matter, or if you want, you can say k is equal to yx. All these are equations connecting these two components that are inversely related. And remember, when one component increases for inverse variation, the other one reduces. It's the opposite of direct variation. When one increases, the other one has to increase. When one reduces, the other one has to reduce. So these are the equations connecting. Now they say we find the value of k. Why it's important to find k? It's because this will help us to have an equation of variation which can help us solve any component. So we will pick this, or if you want to pick this, you get to the same answer. So I'll pick this one, which is direct. So I'll say k is equal to, what is my y? My y, they are saying y is equal to 12. So I write 12. What's the relation? Multiplication times my x is equal to 2. Therefore, simply put, my y is equal to 24. So k is equal to 24. That way, the teacher will be very happy and give you a mark. Now, when you get your k, it's very important to come back to the roots, like I'll come to this root. We know what k is. So I'll just say k is 5. So I'll say 5 is equal to yx. This is an equation of variation. It will solve any component if you want x, as long as you have any of these to solve. So we go to question number 2, where they are saying this one, value of x when y is 6. So just put 5, which is our constant of proportionality. They want the value of x when y is 6. So we write our 6 here and x there. So simply put, to solve for this, as usual, now we can solve comfortably whichever direction. Our x therefore is equal to 5 over 6. And this way the examiner will be very happy and mark you that as correct as well. Then we go to the last component of it, where they are saying value of y if x is equal to 4. We use the same thing, the same equation. So we continue. Let me just put this nicely. So we continue. So this will be the same as value of y if they want the value of y if x is equal to 4. So we know the equation of variation is the same as 5 is equal to yx. So they want us to solve for this. So we substitute 5 is equal to, where there is x, we put 4. So it will be the same as 4y. The reason why I've written this is because always we start with a number so it doesn't look like any value of money. So here we were solving for y. So divide this one by 4 and that one by 4. Therefore, our y is equal to 4 into that. It's 1 over 4, or we can reduce it further. Y is equal to 1.25. This will be our correct answer, and the teacher or the examiner will be happy to mark you that one correct. So we've looked at indirect variation example, direct variation example, and we are going for today, we are going to look at the joint variation example, since we mentioned it before we look at any other things. So let's do that.